Okay, hello everybody. Good morning, good evening, good afternoon. This work is about text anonymization in using LLMs. I will raise some issues and recommendations. First, notes. I will address LLM as a Gen AI, such as ChatGPT, but not BERT. I will explain a little bit about BERT and GPT. I'm not talking here about attacks on LLMs, rather using it properly. And there are several issues, maybe there are several issues that I didn't raise here in this presentation. First, I will explain the points, and after that, I will I will give explicit examples. There are two types of LLMs. They are have different purposes. One is ChatGPT and its colleagues. It's Gen AI. In this presentation, I will refer in the code name of GPT or LLM to this group of Gen AI tools. And the other one is BERT and its variant. Their purposes are different. GPT generates text, while BERT understands text. The differences between them from the point of view of architecture and training objectives are here. GPT uses a transformer decoder, which exactly produce word by word by word by looking backward in the first and previous words it saw and generate. BERT uses transformer encoder, which is bidirectionally. What in bidirectionally I mean it gets a sentence and look at the sentence from the beginning to the end and also from the end to the beginning. The training objectives are as follows. GPT use plain text in order to generate, to predict the next word. It sees the words and predicts the next word by training on the plain text it receives. And it also uses human feedback in order to improve its quality. BERT predicting the missing words in a sentence. The BERT gets a sentence with a masked word, and from the surrounding word, from the beginning to the end, and also from the end to the beginning, it predicts the missing word. This way, it's learned the language and understand the sentence and the language. In essence, GPT generates text while BERT understands text. This is summary of the previous slides, and with also several additionals. Now I'll refer to type of challenges in LLMs. Human challenges followed by computational challenges, and human and computational challenges. The human challenges are self-sense, one of them is self-sense of security. We are, as human, trusting LLM, even though we shouldn't. we are assuming that they are doing a great work, complete work, but they don't, especially from the PII point of view. Superficial reduction versus a true anonymization. The LLM may do a good job with the direct identifiers and eliminate them or reduct them. And it may many times fall with indirect identifiers. And we as a human see the direct identifiers that was reducted and thinks that the text is anonymized. There are privacy standards of GDPR and HIPAA, which we assume that LLM is following these rules and requirements, but they don't. I tried it. They don't. Now I will address human challenges followed by computational challenges. There are bias amplifications. When the LLM is trained, there is a bias in its set of training text. So there is also bias in the demographic patterns that the LLM can understand and succeed in anonymization. There are nuance and context limitations that the sensitive knowledge and information cannot be revealed by LLM, and thus it cannot be anonymized. There are prompt design problems. It's a very crucial problem. The quality of the prompting is one of the basic step for a good output. I will show a few examples on there. Privacy requirement limitations addressing the regulation requirements. The LLM may misunderstand the privacy regulations of GDPR and HIPAA, even though it gets the regulation. Of course, something that we all know, hallucinations of the LLMs, which give us a false information. Computation challenges. The cost is gonna be very high with a lot of documents in order to do anonymization. Contextual misinterpretation. LLM may misinterpret the sentences and will do wrong anonymization or incomplete anonymization. Complex data types. LLM are good with plain text, but they not working quite well with a complex data set, data types. I will show also on this an example. Inconsistency of using schemes. LLMs are not consistent with the anonymization schemes. So the results, the output will be different. Domain expertise. There are maybe PII which are related to a domain specific, which the LLM will miss. Text anonymization by LLM. What I mean text anonymization by LLM, at this point, we give the LLM text, a plain text, and asked him to anonymize it. However, there may be times where the LLM will take the plain text and put it into its repository and use it later. And the one in the few days after that can ask on this text questions, and the LLM will reveal its the knowledge that it was supposed to be anonymized. Okay, now we are going to human and computational challenges, inconsistency and variability. LLMs will produce different outputs. Even for the same LLM, we will get different output for the same question and input. Excuse me. One of the key of the LLM is randomness with each tool. So because of the randomness, the output is also gonna be sometimes random and not consistent. From the point of view of applications, the LLM will produce one document with a great anonymity, and the other one will less great anonymity. Because all of that, the reproducing the same experiment will not be succeed, because there is a randomness in the system. Now I will give a few examples. The first one, I gave the LLM the prompt, please make the following text completely anonymous. And I gave it this text, this paragraph. The answer of the Gemini, the first answer of Gemini, was rephrasing the text and revealing a first name and also a gender. Exactly the same question with the same input raise a different answer from the same LLM. Of course, rephrasing the text and hallucinating, which the word former was not in the origin text, but it added into the answer of the Gemini, and also the first name. I did it also on Claude, and Claude uses the scheme, the anonymization scheme, but the gender was revealed, and also a unique knowledge, wooden leg, also revealed. And the next run on the same Claude will produce the same answer, but a different scheme. In the first run, it was the name one, and the second run is person one, and so on. Another experiment, I asked the LLM, please do not rephrase the text. And the answer of Gemini was quite good. It uses a anonymization scheme, and also masked the wooden leg with a medical information removed. But it's left the gender of the word man. The second run did the same answer exactly. However, the scheme of the wooden leg was different. I gave it also to Claude, And the answer was the same as before. And in the previous slide, I ran it twice, and it's different with a different schemes. I did another experiment, and I asked him specifically to redact names and gender. The Gemini did quite good work, as you can see. The second round of the Gemini did also the same task good with a different scheme. I gave it also to the Claude, and Claude did address the gender in a plural way. And the second run was the same. Okay, now I will address the problem of complex data types. This is a plain text. I asked him to anonymize it, and it did a good work. Another text, it did also a good work, and so on. On the plain text, the LLMs are working quite well. However, within a complex data types, here is the table. These are the results. It reveals the location. It reveals a bank. It reveals also a airplane, exact type of airplane. Also religious. It is also, and also hallucinate. John Doe, what's not in the text, and Michael Smith also, and so on. It's not a good result for anonymization. I gave a riddle to the LLM. I gave it anonymous text and asked him to reveal the person we are talking about. Is anyone here can guess whom we are talking about? Anyone?
Melania.
Exactly, Melania. Also, the ChatGPT did it, and it did a remarkable work, as you can see. Exactly what was written, and also Gemini and Claude. Okay, I gave it another riddle. Can anyone guess?
Some rapper, record producer, politician, mainstream, hip hop. I know. Tupac.
No.
No. Fashion design. Oh, well, I have canceled him from my list of names.
ChatGPT gave the answer of Kanye West.
Yeah, I know.
And it was right.
Yeah.
And also Gemini and Claude. So what is the future of anonymization? We will give the LLM the anonymized text, and it will reveal almost everything. Okay, I gave it another riddle. Can anyone guess? This is hard.
Well, it is long to read.
No, but it is hard. It is hard.
Yeah.
Gemini also wrong about it. It's not Jaco. It's Amado, vice president of Argentina, and it was wrong about it. So if there is enough text in the internet or enough knowledge that the LLM grasp from the internet or from the data set it was trained off, it can reveal the knowledge exactly as we saw with Kenya West and Melania Trump. But if the text is not appear very often in the internet, it cannot. So there is a future. Now I will go through several recommendations. One is when we are trying to use anonymization by GPT, we should take into consideration all the points I raised here. Create a dedicated anonymization AI tool. I'm now working on it. There is a first result are quite good, also on Hebrew. We need to build a prompt designed exactly for what we need. As we saw in my presentation, that the different prompts produce a different answers. As we can ask him to do a full anonymization, medium anonymization, or low anonymization, and there can be different ways to do that. Even if we have a dedicated AI, it will be not complete, not perfect. However, if we will have a dedicated AI, maybe we can use it also to de-anonymize the text because it's specialized on this task. Nowadays, there is ongoing work on cracking encryption by using AI tools. If they succeed even partially, I think that the future of anonymization, document anonymization, will not be so good because it seems that de-anonymization can be work quite well. Thank you all.